Okay, I think we're good. All right, you guys have your notes out, ready to go? Okay, we did number 45 yesterday. We were working on our like linear equations, essentially from a word problem. We're gonna do a very similar thing today. We're just gonna do 2 more word problems and then we're gonna be done with for a p.4 for right now. So this
Are we moving to
Yeah.
p5 today?
we're gonna move to p5 today.
All right.
We are gonna finish p4, so you'll have p4 homework, but we will definitely not finish p5, so you'll only have 1 homework for next class. Which I don't think I see you tomorrow. I think I see you Thursday, correct? Yes, because tomorrow's a day 1. All right, so we do need our graphing calculators again. And for those of you looking, this problem is number 46. I think it's the second one on the paper that I gave you that has all the word problems. If not, it's also on the board. You can just check it out there. This is a lot of graphing calculators, so I just want to make sure you have that out. As you're getting it though, I'll read it. It says, Mary Ellen plans to invest $18,000, putting part of the money X into a savings that pays 5% annually and the rest into an account that pays 8% annually. Okay, first thing we want to do is figure out what are our possible values of X. It says that she puts part of the money X into a saving account. How little could she put in a saving account and how much could she put in a saving account? What's the smallest amount? What's the biggest amount? We'll go even smaller. Technically, she could put $0. 1 cent. We'll just say 0 and then we'll just do a less than X. And then the greatest amount that she can put in is 18,000. Good as the total is the whole amount, 18,000. She could put 18,000 in her account. Cool. Those are our X values. We can go anywhere from 0 to 18,000. If she invests X dollars at 5%, write an equation that describes the total interest received from both accounts at the end of 1 year. Okay, so the total is our interest. Our total interest is our capital I, and that's going to be equal into the first account plus the second account. Okay. If she invests $0 at that 5%, oh sorry, if she invests X dollars at 5%, how would I write that as an expression?
We're using y.
No, we're technically not doing y equals mx plus b, but we are going to use x. Her amount of money will have 5% interest. 0.05 x, period. That's all I want. Very good, Alea. 0.05 x. That's how much she's going to make for the amount of money she puts at the 5% interest. How much is she going to make when she puts it at the 8% interest? 0.08. Good, we could use y. I'm going to argue I want to use the same variable, so I need an expression that uses x to tell me how much is left. So if she puts x in at 0.5, how much will she have left to put in the 8%? 18,000 minus x. Probably ran out of space here. We definitely could use y, however, I would rather us use one variable because I'm going to plug in just one equation into my calculator. So I'm going to do 18,000 minus x. All right, that's my equation. Letter C says graph and trace to estimate how much she invests at 5% if she earned $1,020 in total interest at the end of the first year. Okay. As we put this in the calculator, I want this equation to be your y1, and I want that $1,020 to be your y2 because I want to see where they intersect. We've done the trace, we've done the finding, but I really want to see some intersection points. So we're going to go do that now. Basically, we're just kind of playing around with the calculator to remind ourselves all the things that we know how to do with it. So I'll go put in my y equals, my y1 will say 0.05x plus 0.08 parentheses 18,000 minus x. One thing I do want to remind you is make sure it's 18,000 in C period. We were doing this the other day and a lot of people were 1,800 and then they were getting the wrong thing. While I'm here in Y2, I'm going to write 1,020. Everybody okay with that? Okay, now my window from earlier was just a standard window and that is not good enough. So let's go think about what my window should be. In these word problems, my window is always gonna be 0 for my mins. X min and Y min are both gonna be 0. Now my X max, we wrote what our X's was between, right? Earlier, we said X had to be between 0 and 18,000. So what should my X max be? 18,000, very good. That is a really big number. We normally have much smaller numbers, but it just depends on the problem that's being dealt to us. We just have really big X's right now. Now my Y's, my Y min is 0. I don't know why it says 7. Okay. My Y max, I need to at least see that line at Y2 that I have drawn. And remember that Y2 is 1,020. So I need it to be bigger than 1,020. I'm probably gonna put 2,000 or 3,000 just so I know that I can see it. I think I'll go just 2,000. That should be plenty. Perfect. You see a nice little intersection like I do? Okay, if not, let me come help you. Do you remember how to find that point of intersection? Second trace, intersect. You have 0.5x, not 0.05, and then 0.8, not 0.08. Who else needs help with their calculator? Making my way. Oh, you gotta put some equations in first. Remember our X max is gonna be our biggest X is 1,000, so I need your X max. I'll go to your window. Okay, your window. Min should go to 0. For what? Okay. So for like some. Just press. Zero. Good, and then X max, we just said that the biggest you could invest in one account is 18,000, so I need my X, so at least 18,000. What'd you do? And then your Y max, the horizontal line you had is 1,020, so I went to 2,000, so I could definitely see that intersection. You good? Did I help you well? You good, Kate? Yeah.
Yeah, you got it.
I got you. All right, everybody okay? What was that point of intersection we found?
But you just asked, clearly you know that you're.
There's a.
I got 14.
Good, I got 14,000 as well. Okay. Now, letter D says use your grapher to generate a table of values. I'm not doing a table of values. I just don't find that important. What I do find is what we just did. So we're gonna do what we just did, but we have another number. This time I want my number to not be 1,020. I want it to be 1,185. What do I need to change in my calculator in order to get this answer out? My Y2 now needs to be not 1,020. It needs to be 1,185. And then I do the exact same process. Second, trace, intersect.
Club sandwich and onion rings coming right up.
Excuse me. Man, I thought I was gonna get out of it. Last year it started doing ads on this. And I thought it hadn't given me an ad yet, and I was like, oh, I'm out of the woods, but apparently I'm not. Good. 8,500 is my next number.
You gotta put like an airplane. So, yeah,
Oh, is that how I cheat the system?
that's what I did.
I put it on do not disturb so nothing else comes up, but I never thought to put it on the airplane. All right, are we doing okay on that? Got it. We are gonna skip 47 for right now, so when you're ready, we're gonna move on to 51.
Oh, I had a question,
Mhm.
you check out my back.
I would love to.
Oh, cause you didn't do 0.08. This right here. You just typed in your A.
Just like you did 0.05. You put the 0.8, that's not the same thing as 0.08. All right, how else we doing? Everybody's good? Okay, good. All right, the next one, we're not gonna use our calculator, and I want you to flip your paper over, because 51 is technically on the next side. We're gonna skip 47 for today. If I feel like going back to it later, we'll deal with it, but right now I'm gonna skip it. I will need my calculator to do some very simple calculations, but not any graphing right now. Okay, this problem says, America's personal consumption expenditures from 1998 to 2003 in trillions of dollars is shown in this table. So I've got all my X's on top, I've got all my Y's on the bottom. The points that line up, that's 1 point, that's a point, that's a point. It says write a linear equation for American spending Y in terms of the year X using these 2 points. We're gonna use these points and we wanna write a linear equation. Do you know what I do first to start?
Midpoint.
Not midpoint. Slope, let's find slope. Let's find that slope and then we can plug it into Y equals mx plus b and solve from there. So m for slope is going to be 6.3 minus 5.9 all over 1999 minus 1998. Nine is 0.4, and then 1999 minus 1998 is just 1. So my slope is just 0.4. Now you can do this a couple different ways, but even though I know I want it to be in slope intercept form, I'm going to use one of the points and put it into point slope form and then simplify it down to slope intercept, okay? So I don't care which point you use. We'll call this one x1, we'll call that one y1. And I'll plug them in accordingly. So we'll do y minus 5.9 equals 0.4 times x minus 1998. We doing okay so far with that? Okay, distribute to simplify, y minus 5.9 equals 0.4x minus 799.2. And then we'll add that 5.9 to both sides. So negative 799.2 plus 5.9 is going to be minus 793.3. So that's my equation now. We are not going to put this on a graph, but we could put this onto a graph in our graphing calculator. We could just throw it in, we could graph it by hand. We are not going to, but that's our equation that we're going to use for everything else. Letter B and C say using the equation, estimate Americans' expenditure in 2002 and in 2006. For both of those, I'm going to plug them into the equation. Which variable do they go for?
X.
The years go with X. Yeah, so they go for X. When in doubt, go back and look, because every so often, like time is generally X, but every so often it's not what you think it is. So I go back above and I go, okay, 2002 and 2006 are similar to these numbers up top. So I'm going to plug them in, okay? I know that 2002 has an answer up here. We're going to see if it works with the general equation that we made, okay? So we'll use our equation. Y equals 0.4, but instead of X, we're going to write 2002 minus 793.3. Point 4 times 2002, and then minus 793.3. Y equals 7.5. I like to do an oh duh check, like does that make sense with what we're doing? If you go back and look at the graph, 2002 says 7.4, 7.5 is close enough. I know it's in trillions of dollars, so that is kind of a big difference, but compared to 7.0, 7.8, 7.5 and 7.4 are close enough, so I'm okay with that. Again, generally it's hard for things in real life to be related strictly linearly, so we're just making an estimation with this linear model. Okay, we're gonna do the same thing with C, so go ahead and plug 2006 into your equation as well. I got 9.1. And to me, that seems like it would make sense. The other numbers were 7, 7.4, 7.6. If I go 3 more years, 9.1 doesn't seem like a crazy number to get to. Now, letter D says superimpose it on a graph. We're not gonna do that. We're not gonna do like scattered points like that, so. We are done with this section. I really wanted to do 51 because I promise there's a question either on your upcoming quiz or the next test that looks just like this. It's got kind of these weird numbers, it's got years, so I wanted you to practice seeing an example like that, okay? Anybody have any questions now that we're done with p.4? Okay. We're gonna keep going into p.5. I still have 20-ish minutes, so we're gonna see how much into p.5 we can go. This is all quadratics. What do you guys remember about quadratics?
Like.
Malaya just starts laughing. Equals 0 and squaring, good. Anyone remember which shape a quadratic makes?
Circle.
A U? A parabola, right? We are gonna do a couple graphing calculator problems. When you're solving a quadratic, there's a couple different ways that you could do it. The first way is to just graph it in the calculator, okay? So we're gonna go graph this number right here, or this equation right here in the calculator. I'm gonna go to my y equals. I'm gonna make sure everything is cleared out.
How do you know it's 7? How do you figure it out?
I know Miss Hollis has this cute trick and I don't know it. Anyone know Miss Hollis's reset cute trick? Chase?
Second and. Sorry, second plus sign 7.
So, yeah, listen to Chase Alea. What was it? Second plus 712?
Second plus sign 7.
Yeah. That's it.
Can I show you?
Like that? I don't ever reset my calculator, but I know Hollis does all the time. What's that? Okay, so I'm gonna put that in. I've got x squared plus 7x minus 3. Okay. If your window is crazy like we just had, right? We had windows at like 18,000 and 2,000 and it's not visible on my graph right now. To put it back to a normal window, you can go to zoom and go to Z standard, go to number 6. Go to zoom 6, and that will set you at positive 10, negative 10 in both directions. So that's kind of how I reset my calculator. Now, even though I can't see the bottom of this U, I'm okay with where we're at, because when I say solve graphically, what answers do I want? What do I want you to find for me? X what? X intercept, very good. What's another word for my x intercepts for quadratics? One starts with an R, one starts with a Z. Zeros. And then does anyone remember the R word? Roots. So if I say solve, find the x-intercepts, find the zeros, find the roots, I'm looking for all the same thing. So we are going to go to our graphing calculator, just like we found the intersections, we're going to go find our zeros. So if I go second trace 0, note that you have 2 of them, so make sure that you're cheating to one side or the other so you get both of them. So I'm going to go left bound. Left bound to it. There you go, left bound, right bound. My first 0 is at negative 7.4, just around one place after this decimal. And then second trace 0, left bound, right bound. Now it's 0.4. What's up? Do the next one if you're ready without me. No sign change. Okay, that means that you didn't go fully left bound right bound. So go second trace again.
Wait, why are they doing this?
So now we're left, so you're left with that 0, so it has center. And then now I want you to use the right arrow to scroll. Keep going, keep going, keep going, keep going, keep going. We want it to now be the positive side. That's good because it's one was on the left, one's on the right. That's good. Enter and again. You wanna have one on the negative y and one on the positive twice.
What are two?
Because mine crosses the x-axis twice. What's your graph doing? Where is your axis?
Oh, it's true.
See how I see my axis? Where's your axis? Like, see how you know when you said what? No, I don't know right now. Did you reset it? Like, no, I need to wire you money.
The standard.
Big things, big deals. Yeah.
Okay.
Well, I got to go on orange. Okay, there's your X. Okay, graphs again, let's see. I don't know why your X is in there. So you went around this guy, right? Now I'm gonna do second trace zero again, but I wanna cheat it and get around that guy. So go second trace. Good, zero, and then now bring your little cursor over here, so yeah, right arrow, yep.
So this is one on.
Yes, they want you to be below. Yep, press it, and then now right down, go above it. Yes. Think about left bound, right bound is like, I'm just getting closer to it, so like I'm on the left, I'm on the right, and then eventually it's gotta be in between those two places. Sorry. Good, okay, so you found that one, so now we're gonna do second trace again. Good, good, and then now you need to your spike guide all the way over, so right arrow, the left arrow. All the way over. Okay, yep, a little bit higher, good, see how he's left of the zero, good, press enter, now go right a couple, so that he's below, good, press enter, yes, there you go. All right, you have two options on the other one, guys, if you haven't done it yet. You can either put this in your Y1 and this in your Y2 and find where they intersect each other. Or what I'm gonna do, just kind of keep what we have been doing similar, is I'm gonna move the 8 to the left side. So everything is on one side of my equation, and then that will all go in my Y1 and I'll find the zeros. So Y x squared minus x minus 8 graph, okay? And I'm gonna go find my intercepts again. So second trace 0, we want to go left bound of the first 0. I'm going to the leftmost 0, right bound a little bit lower. My 0 is at negative 2.4. And then my second 0.
Not a sports scientist, but I invest in Invesco. Gives me a variable.
Stop.
Everybody does.
I know, I didn't do it after he told me. Sorry, Chase, I'll go do that in a second. My other 0 is 3.4. If I go to airplane mode, can I still airplay, you think? No,
Oh,
probably not.
you're right.
Dang, that
Oh, what am I find out? Just look at. What I could say.
we have literally like
Yeah.
13 more minutes, so I can't.
You're
All right, how are we feeling about graphing? Bring it back to me. Feeling good? Okay. The other way, there's another way to solve quadratics. Yep, Sam. Bye. That was one way to solve quadratics is graphing. Another way is by getting rid of the square by doing a square root. This is an easy way. You can't always do this, but if you can ever get like something squared by itself, you can just square root both sides in order to solve, okay? So that's how we're gonna do these couple problems. Try and get your x squared or something squared all by itself, then we'll square root both sides. This first one, if I divide by 9 on both sides, I get x squared equals, and I know it's tempting, do not put it in the calculator, 16 over 9. 16 over 9. Now, we are good because it says x squared. I can get rid of that square by square rooting both sides. You guys okay with that? All right. The square and the square root cancel each other out, so I'm left with x. And then now I'm going to square root the other side. What's the square root of 16? What's the square root of 9? Good. And because I square rooted both sides, what also needs to be included in my answer?
Plus minus.
Plus minus, very good. Because I square rooted both sides, I get to put a plus minus in my answer. Let's do one more together, and then I'll have you try the last two on your own, okay? All right, this time, my x squared, I've got like little quotations around that. My x squared is x plus 1, so I need to get that by itself. How do I get rid of that 3 to start? Divide by 3. So I've got x plus 1 squared equals 3. Now, I know it's ugly, but I want you to square root both sides. Square root, square root. The x plus 1 squared, so under the square root cancels that square, so I'm left with just x plus 1. Now, you cannot simplify radical 3, do not put that in your calculator, but don't forget that we have to have plus or minus radical 3 as part of my answer. Now we're gonna put subtract 1. I personally like when you subtract 1, put it in the front. So it's gonna be x equals -1 plus or minus root 3. I like the radical to be the last thing that you see, so that, because if I wrote plus or minus root 3 and then -1, sometimes our radical sign like goes a little farther than it needs to, and it's that -1 is not included under the radical, it's separate. So I like it to go first. And this, while it's ugly, is my final answer. Can you try the next two either by yourself or with a neighbor? Perfect.
Can you like distribute it first? Like
You can, but that's gonna make it way harder. We will do problems where it's distributed, but if I have it without distributing, it's way easier if you just square root both sides. I've got my answer for a C on the board, if you want to check that. Notice that when at the very first step, when I square root of both sides, I have to do plus or minus 12. I don't just get to do positive 12. So I have to set 3x plus 4 equal to positive 12 and 3x plus 4 equal to negative 12. So my two answers are 16 over 3 and -8 over 3. Anybody questions on C? Okay, I'm gonna jump over and do D then, if that's okay. Whatever. I don't even care. Okay, I've got my answer for letter D. Take a second to look at that, and then I want to talk about it. Because I'm sure that some of you stopped where you were.
that one, yeah, there's.
Say that again.
Facts and those are-
This one is fine. However, I believe it's my job as your math teacher to show you the most correct way. Technically, we don't like radicals in the denominator, and this first answer has a radical that goes over 7 and 2. So technically that 2 is also a radical in the denominator. Technically, it's like root 7 over root 2 and by root 2 on top and bottom. So in order to get rid of that, you're supposed to multiply by root 2 on top and bottom. So that's how I got a normal 2 in the denominator, and root 7 times root 2 is root 14. I will accept this first answer, but I believe it's my job to show you that that's not the most correct. If we really wanted to do it correctly, we'd go a step further. Okay. All right. All right, we're gonna do one more type of problem really quick. We got 6 more minutes. The next type of problem is another way to solve quadratics. It's completing the square. However, I believe that's a little tough, so we're gonna save that till tomorrow or Thursday or whenever I see you. Does that seem fair?
Yeah.
Flip your paper over. The next concept, I think you guys are a little bit more familiar with, quadratic formula. That seems like a better thing to do right now, right? Okay, we're gonna try, if we can do all of these, awesome. If not, we'll pick them up tomorrow. Can you remind me, what is the quadratic formula?
Negative b plus or minus. Oh,
Oh, I'm sorry. Negative b plus or minus square root b squared minus 4ac all over 2a. Okay. Now, a reminder that you need it to be in the form ax squared plus bx plus c. I'm sure you guys remember that that's standard form. I just have every year I'll help kids with quadratic formula and they just don't even have it in this form and then they don't know what they did wrong. I'm like, well, you just didn't even start correctly. So make sure you're in that form to begin with. The first one looks like it's confusing and complicated, but it's just because there's a lot of pieces. So we just want to combine all of our like terms, get everything to one side, and then we're going to plug into the quadratic formula, okay? I will go over this, but if you feel pretty confident, you just run on your own and then check in with me as needed, okay? I cannot simplify anything until I get rid of that parentheses in the second part of my equation. So I'm going to distribute negative x to x and negative x to 1. So I get negative x squared minus x plus 3. And then I'm allowed to get everything, all my like terms on the left or on the right side of the equation. So x squared and x squared will actually cancel out to be 0x squares. 3x minus x will be 2x, and then I have a 3 by itself. Now I'm going to move everything to the other side. And I get 3x squared minus 8x minus 10 equals 0. I've got A, I've got B, I've got C. Another reminder is that when you do quadratic formula, please do not use any x's, don't use any x squared, just use the coefficient. So A is just 3, B is just negative 8, and then C is just negative 10. Once you have those numbers, plug them in and let's keep moving with the quadratic formula. Double check, make sure you have all your negatives and positives where they go. That's what I was just doing a second ago. And then you can get solving. (64 plus 120 is 184. Now we always simplify our radical, so I'm gonna go off to the side and I'm gonna see if I can simplify 184 down. I know it becomes 92. 92 I can also divide by 2 to get 46. And then 46 is 2 and 23. That seemed good. I have a one pair of 2, so I can take a 2 out. But my other 2 and my 23 do not have a partner, so they have to stay inside. So that becomes 2 root 46. So I've got x equals 8 plus or minus 2 root 46 over 6. Can I do any simplifying or any cleaning up?
Oh, yeah.
These 3. Can I also do it to 46? No, why not? He's under the radical, you do not touch it. So 8 and 2 and 6 all have a common factor of 2, so I'm gonna make that 4 plus or minus root 46 over 3. Okay. You guys are doing awesome, okay? Everything that we've done so far is fair game for your quiz. That's on Friday. You notice that I skipped complete the square? You think complete the square will be on your quiz? No. No, we will learn it tomorrow, though.